Hey everyone, welcome back to my channel. In today's video, we're going to walk through how to set up RabbitMQ locally using Docker and a Docker Compose file and connect it to our library, HareMQ. Whether you're developing a microservices architecture or just exploring message brokers, RabbitMQ is a great choice. And with Docker, getting it up and running on your machine is easier than ever. Let's dive in. To follow along, you'll need to have Docker installed on your machine. If you don't have it yet, head over to Docker's official site and download Docker Desktop. Also, ensure you have Docker Compose, which is included with Docker Desktop by default. All right, let's start by creating a Docker Compose file. Open your favorite code editor and create a new file called docker-compose.yml in your project directory. I'll put this file in the description below the video. This configuration sets up a RabbitMQ service using the official Rabbit image, which includes the management plugin for a web-based UI. We are mapping port 5672 for messaging and 15672 for the management UI. You can also set up custom credentials by changing the Rabbit default user and Rabbit default pass environment variables. With the Docker Compose file ready, it's time to start RabbitMQ. Open your terminal, navigate to the directory where your Docker Compose.yml file is located, and run the following command. Once the container is up and running, let's connect our library. First, navigate to the documentation, copy the configuration, and adjust it according to our credentials and RabbitMQ host. Once that's done, let's run our app to check if it can connect to the RabbitMQ server. But before we do that, let's navigate to the application, file, and comment out the line with the repository since we don't need to run it. Okay, now let's try running the app. We got an error. Let's troubleshoot it together. Aha, got it. We put the wrong port in the configuration. Let's fix it and start the application again. Now, let's log into the admin panel and check if there's a new connection. As we can see, there is a new connection, so it's working as expected. Once that's done, let's move on and create a publisher and consumer to demonstrate how this library works. Let's start with the consumer. First, create a new file, then navigate to the documentation and copy and paste the example code. Adjust the module name and make sure to update the queue name, routing key, and exchange as needed. In our case, we'll only adjust the queue name. As you may have noticed, I've added OK as the return value to the consume function. This signals that the message was successfully consumed. We can also return error, but in that case, the message will be redirected to a delay queue, and after the delay, we'll attempt to process it again. Now, before running the app, we have to add this module to the supervisor in the application file so that the consumer starts when the app launches. Let's run it and see if the queue and exchange have been created. The queue and exchange have been successfully created, which means our setup is progressing smoothly. Next, let's verify the binding based on our routing key. Perfect! The binding has been established as expected, ensuring that our messages will be routed correctly. Now, let's create a publisher. Start by creating a new file, then navigate to the documentation and copy the example code. Adjust the module, routing key, and exchange if necessary. In our case, we'll stick with the current names. Next, let's run our app and try to publish our first message. But before we do that, let's go to the application file and add this module to the supervisor tree. Now, let's run the app, and using the interactive console, we'll execute this module to publish a message. When we publish a message, it should be routed to the queue we've already created based on the exchange and routing key. Our consumer will then pick up the message and process it. The consume function is configured to display logs, so once the message is consumed, we should see log output confirming that the message has been successfully handled. Let's run the command and see what happens. As you can see, after we pushed the message, it was successfully consumed by the consumer. The logs confirm that the message was processed just as we expected. Now we are going to create another consumer to demonstrate how to push a message to two different queues using the same routing key and exchange. We'll create another module, add it to the supervisor, restart the app, and then push the message. But before we do that, let's modify the log output so we can easily differentiate between the two consumers. Now it's time to publish the message, so let's go ahead and do that. As we can see in the logs, this message was successfully consumed by both consumers, which means it was delivered to two different queues. Now, let's create a consumer with a dynamic number of instances. To do this, we'll start by creating a new file. Then navigate to the documentation, copy and paste the example code, and adjust the module name, queue name, and exchange as needed. Finally, add this module to the supervisor in the application file. Let's also adjust the configuration for the publisher module to enable it to publish messages to this new queue. Now, let's adjust the output message to ensure that we can clearly see when messages are being consumed by this new consumer. This way, when we publish messages, we'll be able to verify that they are being processed correctly by the dynamic consumer instances. By customizing the log output, we'll easily differentiate between the various consumers, making it clear that everything is functioning as intended. Let's navigate to the admin panel to see how many consumers are currently connected to our queue. By checking the panel, we can monitor the distribution of consumers across our setup. As you can see, there are 10 consumers actively connected to our queue, which is what we expected based on our configuration. Now, let's take a moment to compare this with the queue we created in the previous step. If you navigate to that queue, you'll notice that it only has one consumer, which makes sense given that we didn't set up a dynamic number of instances for it. One of the great things about RabbitMQ is that you can easily scale the number of consumers depending on your needs. For example, let's increase the number of consumers to 50 for our dynamically configured queue. We'll adjust the configuration, restart the application, and then come back to the admin panel to verify the change. Once we've made the adjustment and restarted the app, we can head back to the admin panel to check if the number of consumers has updated. And sure enough, now we have 50 consumers connected to our queue, demonstrating how flexible and scalable this setup can be. Now, let's go over the configuration settings for HareMQ that we'll be using in our setup. Delay in MS setting specifies the delay in milliseconds before a message is reprocessed if it encounters an error. In this case, we're setting it to 10,000 milliseconds or 10 seconds. Retry limited parameter sets the maximum number of times a message will be retried if it fails to be processed. Here, we've set the retry limit to 15 attempts. Message TTL. This stands for time to live TTL for the message in milliseconds. With this configuration, messages will have a TTL of 1 year. These settings give us control over how long a message will be retried and how long it will live in the queue before being discarded. It's important to adjust these parameters based on the specific requirements of your application to ensure optimal message handling. If you found this tutorial helpful, make sure to hit the subscribe button so you don't miss any of our future content. Also, if you want to see this project in action or contribute to it, head over to our GitHub repo and hit the star button. Your support helps us keep creating valuable content and improving our projects. Thanks for watching.